Types of models. There are many types of models of subjects and objects. For instance, let's go ahead and take a look at what we call a visual model, the Mona Lisa. So in this particular case, since we've got models of subjects and objects, let's let the subject of the models that we may create be the wife of a nobleman of Florence. She has a rather long name and sometimes goes by the name La Gioconda, but we'll just know her as Mona Lisa. And this is the Mona Lisa painting that was painted by Leonardo da Vinci in 1503. Alright, so our subject then is going to be Mona, the real Mona, not this painting. We can imagine Mona walking around a studio space, perhaps for Leonardo, sitting for periods of time while the artist painted her. The painting shows her at a single point in time, but in reality she's doing lots of things. Mona is talking with Da Vinci, every once in a while shifting, walking during various intervals of time. So Mona was a real person, but all we can know about her we can know through models of her, such as the one that you're looking at right now, the painting. The painting is a model of the real Mona Lisa, and we can call it a visual model or an artistic model if you want. As it turns out, what's interesting about modeling is that really all we can know about anything is in the form of models. In other words, to know a thing means to make models of it. Hundreds of different types of models, each using a particular type of sense that we possess. So there are huge numbers of models for any subject, such as Mona Lisa, the real one, each representing a view or perspective, highlighting some aspects and ignoring others. The process of ignorance is a form of abstraction. So this is where the idea of abstraction comes into play. All right, here's a couple of other examples of artistic models. They're a little bit more abstract. So let's take a look at them. Here's the first one, and here's the second. These abstract versions of Mona Lisa were created very quickly from Adobe Photoshop using filters. Now, it's interesting what the filter does, and this is the case for a lot of different kinds of filters that are used in image processing and computer vision. Filters tend to average or integrate over a space, and what that operation tends to do is it reduces the number of bits in the information needed to represent the Mona Lisa in this case. So this means that the concept of abstraction naturally is associated with information theory and the idea of taking the number of bits that you're using to represent and reducing it to make things more abstract. So abstraction then for visual models leads to simpler looking images. Ultimately, if we were to continue running filters and special kinds of things, then we would ultimately end up having pieces of art that are reminiscent of the De Stijl movement and the Cubist movements in art, those kinds of things. All right, so that's a visual model. Here's another kind of model for Mona. We'll call it the geometry model, and it accents the fundamental geometry, in this case the skeletal geometry of Mona. And we can see by looking at this, we have wrist, we've got elbow, we've got upper arm, this lower arm, shoulder and neck. Although this may look a little strange, this is essentially Mona Lisa, but viewed from a different angle, as it were, a different way, a different perspective, using different information. So this particular picture is just as much a model as the painting by Leonardo. Okay, here's an example of what might be called an animation model for Mona. And it's active, unlike the other one that we just showed. So we see Mona moving around, and we get a perspective of exactly how the joints work and so forth. All right, let's go ahead then and take a look at two dynamic models. Let's look at the first one at the top, which are the two circles and the two arcs. There are two states in this. This is a finite state machine. But the important thing to realize here is that this is a model whose purpose is to structurally represent the dynamics of Mona Lisa. So we're looking at an object, not unlike the painting, not unlike the other things we just looked at, but this particular object is there to accent and explain the behavior or the dynamics. And this is the kind of model that is usually referred to within the domain of computer simulation. One is referring to this sort of model when one talks about simulating a system. In this case, the system would be Mona Lisa and what she did perhaps in the studio, walking around and so forth. So you've got a left, when Mona walks, she puts her left foot down, then she puts her right foot down, and she continues in that cyclical fashion. There are more states that could be added to this to model a proper gait. You could have, say, the heel, the touching heel, or the heel going down onto the ground, followed by, later on, followed by the toe. And so if you start to break down the geometry, you end up creating more states in this finite state machine. Let's go ahead and take a look at the other model. Okay, this is a difference equation, and it shows that we're going to make this represent the amount of space or the length that Mona walks over time. So t is our time, and x is how far in terms of feet that Mona walks. Time will be measured in seconds, and x will be measured in feet. And so we'll say that this expression shows that Mona walks at a speed of 1 mile an hour, which roughly equals 1.5 feet per second. We can only know the real Mona Lisa by its models. Clearly the thing that stands out from an artistic standpoint is the painting by Da Vinci. But the other models are also valid and present other ways of looking, quote unquote, at Mona Lisa. There are hundreds of different model types. We've just looked at visual, artistic, the visual and artistic being one, another being geometry, another being animation. And the last one we looked at were two different dynamic models for Mona Lisa. So in the visual or artistic model, you've got sketches, painting, sculpture, multimedia in the physical sense. And this is how you actually create art, which represent models of targets. In science, we have geometry models, animation models, and dynamic models. And there's a big crossover between between art and science. They're both after really the same thing. They're just looking at different ways of viewing Mona Lisa. And they all represent equally fascinating ways of seeing.